A quiet classroom. On a wooden table sits a battery, a switch, and a straight copper wire. Next to it lies a small compass. A student flips the switch. The moment current starts flowing through the wire, the compass needle suddenly shifts. Everyone looks surprised. How can electricity affect a magnet? This simple observation puzzled scientists for years. It revealed something remarkable. Electricity and magnetism are not separate forces. They are deeply connected. And it all begins when electric charges start moving. Inside every metal wire are countless tiny particles called electrons. Normally, they move randomly in all directions. But when a battery is connected, the electrons begin to drift in one direction. This organized movement of charges is what we call electric current. When charges are stationary, they create only an electric field. But when charges move, something new appears in space around them. A magnetic field. So every current-carrying wire quietly creates magnetism around it. Imagine zooming in around the wire. Instead of emptiness, you would see invisible circular patterns surrounding it. These are magnetic field lines. In 1820, scientist Hans Christian Ørsted demonstrated this for the first time using a compass. Whenever current flows through a straight wire, magnetic field lines form concentric circles around it. To determine the direction of this field, we use a simple trick. Hold the wire with your right hand. Point your thumb in the direction of the current. Your fingers curl in the direction of the magnetic field. This is known as the right-hand thumb rule. Now imagine a tiny charged particle flying through space. Suddenly, it enters a magnetic field. Instead of moving straight, its path bends. Why? Because magnetic fields exert a force on moving charges. This force always acts sideways to the motion. The strength of this force depends on three things. The charge, its speed, the strength of the magnetic field. Because the force is perpendicular, the particle often travels in a circular path. This principle is used in powerful machines like particle accelerators. Now let's take a wire carrying current and place it between two magnets. The moment current flows, the wire jumps slightly. It experiences a force. That happens because each moving charge inside the wire feels the magnetic field. All those tiny forces combine to push the wire itself. Scientists use Fleming's left-hand rule to determine the direction of motion. Thumb shows the force. First finger shows the magnetic field. Middle finger shows the current. This simple interaction is the working principle behind electric motors. Look around your home. Fans spinning on the ceiling. Speakers producing music. Electric vehicles moving silently. Inside all of them, electric currents interact with magnetic fields. These forces convert electrical energy into motion, sound, and useful work. What began as a tiny compass movement became the foundation of modern technology. So the story is simple but powerful. Moving charges create magnetic fields. Magnetic fields exert forces on moving charges and currents. Together, they form the science of electromagnetism. A discovery that started with a small wire, a compass, and a curious question. And it continues to power our world today.